It's just over 15 minutes that you have to pay. Dude. I didn't say that. I'm using the free version. Okay. All right, here we go. Alex, Jordan just read guideline number 1. Okay, guideline number 2. Kira, can you help me read guideline number 2, please?
You write sums of differences quotients.
Good. Guideline number 3. Can you please, Ms. Gibbs?
Sometimes you're writing one side in terms of sign and functions only.
And last one, Max, can you help me?
Always keep your goal in mind as you manipulate one side of the expression. You must keep in mind the form of the expression on the other side.
Perfect. So last night we did all of example 1. Okay. So today we are going to try to finish all of 2. And then guess what? You get to do your homework. I know. And I don't see you until Friday. You can go celebrate. Okay. A. Can we start on both sides? No. One of the guidelines said to pick the side that's more difficult, the one that's scarier. Which side is scarier? The left. All right. You do need to number your steps. I need to be able to follow. Where am I going next? So the step 1 is always the side that you have decided on. Okay. Okay. Step 2. Raise your hand if you can tell me what to do in step 2. Again, it's not a lecture that I can just tell you what to do. You need to help me. Cyrus. Oh, so you're going to change everything into sine cosine?
Yeah.
Okay, let's listen to Cyrus. He knows. So copy this down. Sine of theta times cotangent class is what over what? Cosine over sine. So cosine, and please do attach theta after it. What's tangent then? Good. This is one of the guidelines, am I right? Perfect. What's your goal, by the way? Because one of the guidelines says keep your goals in mind. What's your goal? Yep, make it secant. What's next? Maddie? Can I add them? Should I add them? What do you need to do to add them? Yep, same basic rules still have to apply. What's the common denominator that we should have here? Can I multiply sine and cosine and make that my common denominator? Yeah. If you have 2 and 3, the common denominator would be 6, right? Because we just multiply the 2. Okay, so it's the same basic rule of that is still here. All right, so here's my common denominator. I'm going to have sine times cosine in both. Class, what's my new numerator on the first one at least? What's my new numerator on the first one? Beth? You guys agree with Beth? Kelly, what's the second one, dear? Yeah. What do you want to do next? What do you want to do next? Yes, the denominator, they are exactly the same. So for sure, that's the whole point. So we can totally combine them. Okay. So sine of theta. Oops, I meant to say cosine of theta. Okay, on the top, I have now cosine square of theta plus sine square of theta. Anything like jumping out at you? Anything screaming at you? Samuel? Doesn't it? Okay, you're going to need to know all of these identities. Okay, so let's write them on the side. Right now, the main 3, so identities you must know. And no, you can't have a cheat card or cheat sheet on the test. What are the 3 Pythagoras identity that you got to know? It's like sine square of theta plus cosine square of theta equals?
1.
Perfect. 2 more that came from this. Hannah?
Tan squared theta plus 1 equals theta.
Very good. Tangent square of theta plus 1 equals secant square of theta. And please don't try to memorize too much. How did we get tangent square of theta plus 1 equals secant square of theta? What did we do? We did. We divide each and every term by cosine. What's our last Pythagoras identity here? There's one more.
Isn't it cosecant or minus cosecant?
We can move that around, but there's one more that's not involving tangent or secant. I think you're on the right page. Is that what you meant to say, Kara? Yeah. Okay, then you're right. Okay, these are the three. Do you have to know these?
Yeah.
Oh, yeah. Okay. Okay, then right away on step 5, what can we use? First Pythagoras, second Pythagoras, third? The first one, right? So sine of theta, that's going to be 1 over sine of theta times cosine of theta. Okay, step 6, what do you want to do? Yes, it's multiplication. I can totally distribute. Okay. Now what? Do the same simplifying rule. Can we use that still? Can I simplify sine and sine? For sure. Okay. So step 7 is 1 over. Am I done? Is that my goal? Almost, right? 1 over cosine is always secant. And now you do what? Initial. The reason I'm asking you to do initial is nothing wrong or right or anything better. It's just I need to know, hey, I'm done, okay? I follow all the steps and I got it. This is my favorite out of all mathematics content. Okay. Isn't it fun? Oh, thank you. What a wonderful response to that question. All right, B. I want you to write the first 2 steps on B, okay? Doesn't matter which side you decide to use, I want you to write the first 2 steps. And then I'm gonna just walk around and use your 2 steps and we'll continue from there. Hey, if you can go a lot further than 2 steps, I would like for you to at least try as far as you can go, but minimum 2 steps. Which side do you think is scarier, more difficult, more complicated? Right? Oh, that's interesting. Okay. And it doesn't matter. If you think left is more difficult, then use left. Okay. Whatever you do, though, if you've decided on one side and it doesn't work out at the end, don't erase. Just cross it out and start over on the other side. Because what happened is oftentimes you can see a couple of steps on that wrong side, that you started, that it didn't work out, and then you can manipulate the other side. Okay, so don't ever erase these. Just cross it out so you can see what didn't work. So you can either avoid it, or if it worked, you can use it again. Okay. Number your steps. All right. So Mr. Lopez has this side. If you pick the other side, don't erase, okay? I want you to just kind of start over here somewhere, okay? Step number 2, looks like he did convert everything into sine and cosine. Are these 2 legal? Okay, so far so good. Now what? Raise your hand and you can tell me what to write on the 3rd step. If you started like sine over 1 plus cosine, then just write it on the right-hand side. Okay, maybe we'll do both steps, both sides. What are you gonna do? Can I combine them right now? Sure, because the denominators are the same.
Dang it, Maddie.
Okay. What's our goal for this question?
Oh, shoot.
Sine over 1 plus cosine, right? Can I just flip them right now and call it a day?
Nope.
Please don't. Okay, that will make me cry. what do you do then? You can flip them and put your initial and call it a day. Can you go back to example 1 and tell me, find one of the very similar thing that we did? What did we do? Hannah? Very good. What's that word? There's a word. The conjugate. If you see your goal has a conjugate, you might want to try that, okay? So, the word is conjugate. I see that my goal, my end result, has this. Then that means I might want to get there by multiplying this. And normally, I would like for you to go and add parentheses around things that have 2 or more terms, so you know to multiply and not just to move it over. Is it nice to multiply conjugates? Yep. What do we now have in the numerator? I heard it. What is it? Yes, sir. Very good. On the bottom, I'm just going to put it together. Okay. Step 5. What do you think? Hayden, anything you want to try on step 5? If I factor out, when I go back to step 3, Hayden? Team Hayden, then. What are you going to do? Maddie?
One of the identities, if you like flip it around, the top would be equal to sine squared.
Do you agree with Maddie? 1 minus cosine square is always? And 1 minus sine square is always? Cosine. All right. You are correct, dear. Very good. Remember, what's your goal? Yeah. Okay. Are we almost there? Perfect. Can I simplify now? Perfect. I can simplify one of those, right? So, 6 is my last step. Am I correct? Sine of theta all over 1 plus cosine of theta. And do your nice initial. What if you started on the other side? Could you go backwards and do the same thing? Yeah, because if you notice, okay, if you started here, it doesn't really matter, by the way, because can I multiply both sides by the conjugate? Okay, so if I started here, notice how I'm now going to go in and multiply by the conjugate. Because if you look at your goal, if you started on the right, your goal doesn't have any sine and cosine, right? So that means you have to get rid of them, which is the reverse of what we normally do. So to get rid of them, we're going to multiply by the conjugate. And again, I'm going to go in and put everything that's 2 or more terms in parentheses, so I know to multiply. Then now I have sine of theta times 1 minus cosine of theta all over. On the bottom, I now have what? 1 minus 1 minus cosine square of theta. And by the identity, would you agree that's sine square? Right? Now what do you think to get cosecant? What should I do to get cosecant? This is a little bit of tricky. It needs a little bit of manipulation here. What should we do? I need to get cosecant. And by the way, what's cosecant? 1 over sine. So I want to get 1 over sine along somehow. What should we do here? Should I simplify the sine? Okay, let's do that and see. Hey, if it doesn't work, you can always go back. Okay, now what? You're so close, Kevin. Okay, this is a thing, you're right. This is a thing I want you to remember. If you can, guys, if you can combine the denominator, can you split the denominator? Yeah, because that's a step that a lot of us do forget, that we forget sometimes to split. Okay? And it's totally okay to split if you are adding and subtracting. Okay, and then this is my goal, am I right? 1 over sine of theta is cosecant of theta minus cotangent of theta, and call it a day. Okay. So either way, you should be able to get to your goal. Any questions on these? Some of you will love this. Like, you can live forever on this. Okay. Pick a side. Pick any side. What do you think? Alex, pick a side. Pick any side. What do you think? I'm asking you. Left. Okay. Everyone listen to Alex. His brother might not. Okay. Oh, sure. You just have to be very creative. That's the beautiful thing about mathematics. All right, kids. Tell me what to do. Alex said left. Uh-huh. Should we try that guideline? Yes, because right now I don't know what else to do. Okay. All right, so copy sine square over because it's already sine. Okay, and then tangent is now what? Sine of theta over cosine of theta divided by cosine square of theta minus cotangent is cosine of theta over sine of theta. Okay, great. Tell me what to do, please. Maddie? Good question. Can I go like this? You mean like that? Yes. Good question. Can I do that? Okay, so let me ask you this. 5 minus 10 over, let's say, 7 minus 10. Is that right? Okay. I mean, remember, it's good to bring it up so we can avoid it. Okay, so you can't do that. Now what? Samuel? Right. That's one of your guidelines. If you have subtraction and addition and they're fractions, you might want to find what? Common denominator, right? Because these are all technically can be rewritten like that. So let's find the common denominator for the top. What's a common denominator for the top? Cosine. So this is cosine, this is cosine. Would you agree that this piece right here doesn't change? What's my new numerator? Like this piece right here. It is now what? What is the new number? What am I doing? Uh-huh. Do you guys agree? When I multiply to the bottom, I need to multiply to the top. All right, so that's just one set. This division line right here, could I, in theory, write it this way? Good. Let's find common denominator for the bottom half. What's a common denominator for the bottom half? Sine, right? So sine goes here, sine of theta, sine of theta. So this one maintains its cosine, right? Okay. So Peter, do me a favor. What is my new numerator now for this piece? This one right here. Perfect. Okay. Nicely done. Carly, what do you think? Next. Yeah, the denominators are the same. Let's merge them. Okay, divided by this side. Okay, beautiful. Now what? Christian, give it a wild shot. What do you want to do? I'm dividing. So multiplication and division, I don't need common denominator. Katie?
Flip the fraction on the right.
Yeah. If you're dividing a fraction, can I multiply by its reciprocal? For sure. Okay. I'm going to flip. All right. This requires a little bit of thinking now. Very creative. Use some mathematical ability here. Kelvin?
So on the left side you have a sine squared theta, and on the right side in the denominator you have a sine theta. Can you cancel one of these?
You can't cancel sine square with cosine square.
With the regular sine squared.
What do you mean, like, let me
Sine
highlight.
theta, sorry, sine theta.
Sine, you mean like here? Like I highlight like that?
Not that one. The sine squared theta on
Like
the
that?
numerator on the left.
Uh-huh.
And in the denominator, the sine theta.
No, it has to be from every term. Okay, so I can't cancel those because this pink highlighting right here, Kelvin, does not have a sine of theta. Okay, all right. Cyrus, what? Okay, Cyrus suggests that we should factor out. Should we use that? Can you see what happened when you factor? Is this something? Oh, Kira, let's try. Okay. I'm going to take out a sine of theta. What's left after you take out a sine of theta? Sine theta times cosine of theta cautiously minus 1. Good. Times on the top, I still have sine of theta. On the bottom, Cyrus dropped the F-bomb on that side. Should we do the same? Should we factor it out again? What are we factoring down here? Yes, cosine. Good job, Cyrus. Okay, so that means I have cosine of theta times sine of theta minus 1. Okay. Mary, what do you think? What should we do next? Can we reduce, simplify, cancel those? Yes. Excellent. Okay, so I'm on step 7, which I need to bring it up here because I'm running out of space. I need to erase really quick. So, all right, so that was step 6. Step 7, what do I now have? Sine over cosine. Sine of theta over cosine of theta times, what's the other side? Oh, woo! Look at that, guys. Are we almost to our goal? Almost, very good. And then set 9. We should write what? Not 1, but tangent square, and then Maddie H. There you go. Uh-huh.
For step 7, when you go to step 8, could you instead just say tangent of theta times tangent of theta?
Of course, very good. Okay, so Katie said, hey, if it's right here, can I just write tangent times tangent? Sure, of course. Okay, like I said, there will be all 34 of you will have different solutions. That was fast, isn't it?
It didn't seem like it, because last time it rained, it was like at least after 2 or something like that. I know, but last time 32.
All right, D for dog. I would like for you to write 2 steps. 2 steps. Start with 2 steps. By the way, if you can write all steps and get to the final, that'd be awesome. Way to go. If you know a D, attempt the next two, because we have to finish all of them anyway. Actually, is E the last one? Oh, F. Okay. If we are not trying, there's no way we can do the test, okay? I've said this many times. I cannot lecture this. This has to be from practice. Look at the goal, okay? Look at the step that you have chosen, the side that you have chosen. What's the magic word on this one? Conjugate, right? That's really what you want to do. All right, Kira, looks like you picked the right. Okay, the right or left? Okay, you don't have to do both. You can just do one. And then step 2. The left-hand side, does it have a conjugate, guys? Yeah, so guess what? You should multiply. Okay. So 1 minus sine of theta. Because I have 2 terms here, I'm just going to go and put parentheses so I know to multiply and not add or do something funky. 1 plus sine times 1 minus sine is... We'll let the trash truck go by. Samuel.
Wouldn't it be 1 minus sine squared theta?
Yes, sir. You are correct. And I'm going to leave this here for right now. Alex, what do you want to do next? Consult your team.
The top 3 replaced with cosine.
Yes, sir. Very good, sir. Okay. Are we almost home, guys? Bless you. Lily, what do you want to do next? Consult your team if you need to. Oh, and my computer's bored and it went to sleep. All right, Team Lily, what do you want to do? Yes, I can. So last one is cosine now over 1 minus sine. Is this my goal, by the way? Let's double check. Yep, that is my goal. Very good. Lily E. Any questions for Lily on this one? Going once? So far. Easy or difficult? Easy? Nice. All right, next one I want you to try 2 steps again. If you get stuck, it's okay. Last 2 of 7.4 notes. So I'm looking for 2 steps minimum. If you can go more, that'd be awesome. All right, I'm gonna copy Miss Gibbs. Okay, Miss Gibbs, you pick right side. Cosecant of theta minus sine of theta all over sine of theta. Very good. Step 2. Looks like you converted to everything to sine and cosine. Very good. All right, these are Miss Gibbs' Exact 2 steps. Okay. Raise your hand and you can tell me what to do next. Katie? Yeah. Is that a good idea? Perfect. Okay. So step 3, they both should be sine, right? So this is now sine. What's my new numerator? Sine square. If I'm dividing, everything is divided by sine, class, can I write it this way? Would that be okay? Perfect. All right, Team Meredith, can you tell me what to do next, please?
Instead of like sine over 1, you can flip it to 1 over sine and then
Okay, so Meredith said, so just flip this last one, right, Meredith?
Yeah.
Okay. Is that okay? Yeah, okay. Annalise, what did you say?
combining things like that.
Can I subtract those? They are. They have the same denominator. Why not? Okay. So 1 minus sine square of theta all over sine of theta times 1 over sine of theta. Team Maddie H?
You could replace the 1 minus sine squared theta with a cosine squared of theta.
Very good. Excellent. Team Beth, what do you want to do? Sounds like a good idea to me. Oh, we almost home, guys. I don't even know what my goal is. What's my goal? Cotangent. Am I there? Yes, totally. Cotangent square of theta. And we are done. Beth R. All right, saving the best for last. Cubic and square. All the powers are there. Two steps. Write it in there, and then I'll ask you for it. Here, you get it all done already? No, okay. Try it. You got 4 steps and you're done? Wow. Nick did it in 4 steps. I don't know if he's right, but I just look at it and he said he's done. Henry got 5. Okay, I'm just looking to see. You guys got initials. That means you're done. Okay, I'm impressed. You guys. Okay, I'm truly impressed. Okay, raise your hand if you can tell me what to do from beginning to end. Beginning to end. Anyone has not volunteered? Jordan, yes, thank you. Give it a shot.
1, right, I did the left side, so 1 minus cosecant theta times sine theta.
Nice.
And then I converted cosecant to 1 over sine of theta.
Okay,
so
so
1 minus 1 of
sine
1
theta.
over sine of theta times sine p theta.
Can I put sine cube theta 1 like that?
Yeah.
Okay.
And then you multiply so that it's 1 minus sine cubed theta over sine of theta.
Very good.
So then that's 1 minus sine squared of theta.
Very good. Do you guys see what Jordan did? Because I can simplify these, right?
Yeah.
Very good.
And using the identity 1 minus sine squared of theta is equal to cosine squared of theta.
Very, very impressive. Very good. JV. Woo! Any questions for Jordan? Is that, by the way, is that the end? That looked pretty scary, but was that scary? No, right? And is it okay to make a couple extra steps? Sure. You can have 10 steps and still get to the same spot. No big deal. All right, guess what? We are done.